Hi, I'm Sofia Milosavljevic. I'm a first-year medical student at Harvard Medical School, and today I will be presenting the article Quality Assessment of Meta-Analyses on Cervical Cancer. And this was done in collaboration with the School of Biomedical Informatics and the School of Public Health at the University of Texas Health Science Center at Houston. To introduce the topic, meta-analysis, or MA, is the quantitative synthesis of data from more than one individual study and is considered the highest quality evidence for evidence-based medicine. The challenges of MAs include data heterogeneity and methodological errors, because properly conducting MA requires not only domain knowledge, but also technical skill. The PRISMA reporting guideline has helped improve reporting. However, standards of execution for MAs, for example, AMSTAR 2, aren't routinely applied to assess quality, making it difficult for physicians and other clinicians to know which MAs to trust. Overall, the study's goal was to use MA on cervical cancer as a case study to specifically determine which are the most commonly seen errors in published MA. We hope this will be a first step in elucidating the specific areas of MA that can be improved to better the overall quality of data we are using for evidence-based medicine. Our specific aims include 1, using PRISMA and AMSTAR 2 to determine the quality of cervical cancer meta-analyses by assessing their compliance with each of these measures, and 2, raising awareness of the most missed and most actionable elements leading to low quality meta-analysis. So for our methods, 40 cervical cancer meta-analyses published from January 1st, 2014 to March 1st, 2021 in high impact factor and low impact factor journals were sampled. In a later slide, it will be possible to see that from our literature search, 7 seem to be the natural cutoff between low and high impact factor journals. Then the PRISMA reporting guideline and AMSTAR 2 execution guideline were used to score each meta-analysis according to adherence to the guidelines. For AMSTAR 2, we specifically only used their critical criteria because those were the ones determined to be essential for high quality meta-analysis. The scoring was done by 2 reviewers working independently. Finally, the most missed criteria were determined by calculating the percentage of meta-analyses in the sample that properly executed the criteria. So as shown in this diagram, our PubMed search yielded 799 meta-analyses, from which 295 were excluded after filtering, leaving 504 articles that met our inclusion criteria and were published in journals with impact factors. We sampled all articles with impact factor greater than or equal to 7, n equals 20, and took a random sample of the articles in journals with impact factor less than 7, n equals 20, resulting in a total sample of n equals 40. The final sample consisted of 50% high impact factor articles and 50% low impact factor articles. The lowest impact factor included in the sample was 1.3 and the highest 33.75. Here, based on the top figure, one can see that around 7 is a natural boundary between low and high impact factor journals for our sample. Additionally, the bottom diagram shows a comparison of meta-analyses chosen to be sampled in comparison to all the meta-analyses that met our initial inclusion criteria. Here, one can see the percent of the sampled studies which complied with each AMSTAR 2 critical criterion, including from left to right the categories on the x-axis, as you can see here. And similarly, here's the same graph, but demonstrating the percent compliance with PRISMA criteria. Looking at this graph presents a lot of information at once, but in the next few slides, the most significant results will be elucidated. The average adherence to each AMSTAR 2 critical criteria was 55.6%, while the average adherence to each PRISMA criteria was 82.7%. We note that PRISMA and AMSTAR 2 are not directly comparable because AMSTAR 2 allows for partial answers and has subcategories, making it more difficult to meet a criterion. Further, PRISMA is a reporting guideline and therefore may give credit for reporting a weak procedure, while AMSTAR 2 specifies the procedure that should have been used. AMSTAR 2 critical criteria only contain essential elements of meta-analysis, and thus PRISMA average adherence may be artificially inflated by high adherence to superficial criteria that are not as meaningful to the overall quality of MA. When scoring using PRISMA, the most commonly missed thematic elements are establishing review methods before execution of the MA and defining principal summary measures. The 32.5 adherence each. Reporting performance of sensitivity and subgroup analysis, 65% adherence, and assessing the risk of bias within included studies, 66.25% adherence. Using AmStar2 critical criteria, most commonly missed thematic elements were the inclusion of a list of excluded studies, 25% adherence, establishment of a review protocol before review, 31.3% adherence, documentation of a reproducible search strategy, 33.8% adherence, and assessments of risk of bias within studies, 64.7% adherence. It is important to note that there is a newly revised version of the PRISMA checklist published in 2021 available. This revised checklist is called the PRISMA 2020 checklist and should serve as the new standard for meta-analysis reporting in the future. It is interesting to examine how the criteria we identified as weakly adhered to in our sample overlapped with changes made to improve the PRISMA checklist clarity and specificity on these same criteria. Specifically, there was a clear overlap between the areas we identified as weakly reported and the changes to PRISMA in the categories of registration of protocol, assessment of risk of bias within included studies, and documentation of study selection and inclusion. As a final part of the discussion, I'd like to present some actionable recommendations. Firstly, as best practice, we recommend reviewing meta-analyses before publishing using both standards of reporting and execution. In addition, meta-analysis protocols should be registered using PRISMA for protocols. Then, to further offer suggestions to those looking to conduct a meta-analysis, we suggested pre-establishing a protocol and registering it online, defining the principal summary measures before the meta-analysis is executed, and documenting a reproducible search strategy. For future research on this topic, we recommend assessment of the quality of meta-analysis, comparing journals that required a filled PRISMA checklist for submission to ones that do not, further study containing a larger sample encompassing multiple topics, not just cervical cancer, and a reproduction of our study using the 2021 PRISMA guideline. We would like to show our sources that were used in the presentation here. And additionally, to thank the UT Health Innovation for Cancer Prevention Research Summer Undergraduate Fellowship, grant number RP160015, for funding this work. And if you have any questions, please feel free to contact either myself or the PI of the study, Yang Gong. Thank you so much for your time.